Hey gang, welcome back to Joe Daddy's Garage. Today's video is part 32 in the 68 Mustang Fastback build. Now in the last video, or the last couple of videos, I've discussed the headers, the new headers from TCI, and trying to configure the exhaust system for the car. And all of that is in an effort to make sure everything fits, because you don't want to be at the end of the assembly and have a problem. As I pointed out, I had to relocate the cable for the shifter so that it didn't interfere with the exhaust and had more room underneath. Now, some of the other things that are going to be involved with this as I move forward, as I mentioned, the wiring harness, various pieces and parts that go on top of the engine. There's going to be a radiator, all these pieces that make up the entire car, they all have to fit each other or fit within a space provided for them. So one of the things I'm thinking about that I need to consider is the intake. Now, I will demonstrate what I'm talking about because I have the Holley intake kit right here. And basically, I want to have enough room between the top of the intake and the hood. And there's no way to know that unless you actually put these pieces in place. So the consideration is the TCI suspension, as it's made, is only designed to sit so high or low within the frame rails of the car. You can't really change that. The engine mounts also are designed to sit so high and so low. There's really no room for adjustment. I mean, if you try to move the engine down slightly, you're going to run into interference problems with the oil pan and the cross member, and that's just not how it works. So I'm trusting that TCI thought about all this when they made this happen. Now, of course, they're using or looking at this type of engine right here, which is a basic stock engine. And this is what this is. However, it's going to get some add-ons. So let me show you what I'm talking about and potentially if it's going to fit. Now, we already know it's a snug fit with this big engine in this small engine bay. That's why there's no shock towers. That's why I had to move the air conditioning over slightly. And I'm not done yet. I mean, there's still things to make fit. I have started undoing things. Like I took out the shifter. I wanted to get that out of the way. I've taken out the exhaust, at least the main pipe that I had put in, and I'm working towards pulling the header out of the way. But I got to thinking, I need to see about this manifold. Now, this plate that I have bolted to the top of the engine, I showed that before. That is from a company called Massive. Great plate. Has all these mount holes. You can connect your self-leveling or level engine hoist with. And I'm going to take this back off because I have a bunch of pieces here that I want to see how they fit. In this box I have the base for the intake, and then this box I believe is the top. There's other pieces and parts here. These are some hose connectors. There's also this big plenum piece, this big kind of pipework piece, and I'm not sure exactly how that plays into it, but it needs to be at least test fitted to see how things are going to work. So I'm going to take that plate off and then start working on just mocking up these pieces to see what it's going to look like. To start this process, I'm going to remove this plate made by Massive. This thing is very well made. Thick steel, very strong, welded nicely, and then powder coated. So get all the bolts out of that and then remove the plate. This thing's heavy, so making sure I'm not going to cause any problems when I remove it. Now, I show you these because I've covered up all the inlets for the intake so that nothing could get in there. So there's duct tape covering those openings. I open up the box with the main part of the intake, and this is fairly heavy as well. I mean, this is a big piece of aluminum, but it's thick. And I'm checking it out to make sure there's no burrs or anything on the flanges because, when you mate stuff together, it's got to be tight. And there's also an O-ring type of thing that goes in this. So these look like the O-ring pieces, and it goes into a channel, a groove that is cut along the perimeter. So I'm going through the bolts right now to figure out which ones are which. I didn't look at the instructions, but it's pretty easy to figure out. You do a number count and you see how many bolts you have that match that count. And then I find that there are studs. And the studs don't go into the top of the manifold, they go into the cylinder heads. So the first one I tried to put in didn't seem to go in very smooth, I turned it over and it threaded in just fine. So I'm just going to put a few of these in place just for the alignment process, and then I'll go grab the intake base and set it in place on top of those. And things lined up pretty well except for that little fitting right there. So that'll have to be addressed later. Well, that looks pretty cool, but I do see something that may happen here. This water neck up on top, this isn't going to be relocated. You have to have that water neck for this hose. I'm not sure what this is intended to do, if it's meant to be removed. I haven't looked technically at the instructions for this. I'm kind of going by what I see as a normal setup. So I will continue on. I'll get the top on and the front face. We'll look at that. But I'm going to have to figure out what's going to happen with this. I don't know what that fitting is. It's a very odd kind of shape there. Maybe we have to get a different water neck and replace that one. Here is some instructions. Holley high ram intake manifold kit for 2011 to 22 Ford 5-liter Coyote. So here's the different configurations, and I was kind of just leafing through this. You know, it shows you the different necks and inlets, but when I got to the back, figures it would be on the last page. It says, remove the water outlet assembly from the engine, then remove this tube from the water outlet. So sure enough, they have it listed here. After the tube is removed, tap the hole to 1/8 27 NPT, install a 45 degree 1/8 NPT 2/4 inch hose barb fitting. So here they're showing it interfering, and this is with the fix. Alright, that's simple enough. I can at least, at this point, I think, remove this assembly. Like I can take this fitting off here and then just get this out of the way and then worry about removing that later. So these hose connections, they're basically built for quick assembly on the assembly line. Like you just push it together and it snaps in place and you're done. So that little clip that I'm working with, you should be able to just retract it, and there's a groove there that holds it in place, but you should be able to just retract it. And it seemed to be fighting, so I took that completely out of the way. It didn't really make any difference. It was still tight. So a little bit of wiggling, break loose any kind of buildup inside of that, and it comes off. Put the clip back on and set it aside. I'm again checking the surface here to make sure it's smooth, and I know that there's going to be like an O-ring filler piece that's going to go inside of that and hold everything together. This is just temporary, so I'm just hand or finger tightening these bolts to hold the top of the intake system together. Then I get the inlet for the intake, and apparently there's variations of these. This one, I don't know if there's any difference between one or the other, why this is selected, but I'm sure there's a reason that this one is what we're using. It doesn't really matter to me, just so I know things are going to work. So I'm hand tightening or finger tightening these pieces as well. And you'll notice on the side of this, there are inlets. So I'm assuming you could put like a vacuum connection or something there, but you can also just block those off so that they're not drawing any air inside. So the next piece is, I'm guessing again, some sort of adapter, because the front of this has a variety of threaded holes to where you can put on different configurations. So I'm putting this piece on in anticipation of putting on the throttle body. And you'll see as I go forward in this, I didn't realize we had a new throttle body to put on this, but I test fitted the original anyway. As I was setting this adapter in place here, I noticed there's a hole here. So I'm assuming that it belongs to like a different configuration, like they've made it take a few different ones here, because everything else lines up. There's a hole here as well, and there's one down here at the bottom. And I haven't, like I said, I haven't fully looked at the instructions. This is more about height and how everything's going to interact overall. So I'm okay with that. I feel like that's correct. And as I look at this print, it shows this body with this adapter, just like I put it on, and then it says Ford throttle, 80mm throttle body not included. So I assumed that there was going to be, a regular throttle body that came with this, but I have the intake from the engine, so I'm going to pull this off and see about putting it on, and then we'll continue on from there. So this is a good demonstration just to show you that the factory Ford piece fits. However, I was reading through the boxes. I didn't realize we have a BPK 90mm throttle body. So I'm going to put this on. I'm going to see how that looks. It also comes with apparently an adapter here, and I'll set it up however it needs to be, but this one's going to go away. And I started looking at this intake kit real briefly. So you don't use all of this. I didn't realize, just looking at it, I'm like, I don't know what this is going to do, if that is meant to go around the engine or something crazy. However, this is a universal intake kit, 615-400. And I looked at a video online, and all of this is meant to be something you can cut up. Meaning, whenever it comes time to fit all this together, you can choose which way you want this inlet to turn, whether you want it to go somewhere else, and all of that ductwork can be modified. And it comes with all these different boots, and here's the inlet for the air filter, different sizes, there's brackets and different things. But one thing I don't see yet is the mass airflow sensor. So I don't know, or I don't remember seeing this engine show up with the mass airflow sensor, and I'm going to look around and see if maybe it was ordered and I just don't see it yet. It may be back in my storage area. So I'm going to get this swapped out and we'll have another look at it. I'll just remove the factory style throttle body, get it out of the way, and now I start looking at the BBK system, and I realize that has a thicker area on it that interferes with the fitment on the Holley, where that little servo motor that controls the butterfly. So that's why you get this adapter. Took me a minute to figure out which way that adapter needed to face, but once I did, I just put some bolts through it and ran them down and made that finger tight as well. This is a slightly bigger throttle body than what the factory piece was, from what I'm assuming here. This is a 90mm versus what I'm guessing was an 80mm from the factory. Here's the video I was talking about. This is from Flowmaster, and there it's showing the throttle body. This is on an LS engine. Throttle body configuration with the elbow of the plenum they cut up, and then this mass airflow sensor. And I don't have that. So I'm assuming, as I have to do, that there would be a mass airflow sensor in front of this inlet. But I don't have that. I don't know if it was removed with the configuration or with the truck when this engine was pulled. I don't know. Whenever I received this, it had this rubber plug or plastic plug in this inlet, so there was nothing on the front of this. There was nothing else attached. And I know I have the computer that came with it over there on that bench, but I don't see a mass airflow sensor. So that's on the to get list, I suppose. And then this is what I was talking about, this pipe work. You know, when you see it in the plastic, you're like, what is this for? What does it do? Well, now that I've taken it out, I can see all of these are basically cut points. So you've got a 90 degree, a 45, probably, I don't know, 27, something like that. Varying angles, another 90 up here. And when you cut this, you end up with a flange because you cut in between there. So there's already a flange on the end of both of these, and you just can figure out what you want to use and how you want it to go. So I'm not going to worry about that at the moment because I'm not ready for that. But at least I understand now how this sets up. What I want to do, and I need to do, I'm going to set the fenders back on and maybe see if I can set the hood on or look at it. I'm probably not going to set the hood on because I can already see this sits really high, and I'll move this out of the way so you can see what I'm talking about. Coming in from the side now, that sits really high. I already know there's no way you can use a stock hood on this, but I'm going to set the fenders on anyway, and we'll have another look at it. I also want to point out I'm not doing the full assembly here, so these ports right here, these little recesses, that's where the injectors go, and there is also fuel rails that come with this that connect to the injectors. So all of this has to go on later, but for now I'm just looking at how this sits. Let me set the fenders on. Just a note here, these fenders are a little heavier probably than any other aftermarket fenders that I've used. They feel solid, they fit pretty good on the body, but there's going to be some adjustments that have to be made later on with the alignment holes up on top. But as it is, I'm pretty happy with these fenders. As expected, yeah, no way that hood is going to fit on here. In fact, I'll just take this straight edge, as straight as I can get it, lay it across there and show you. That ain't going to work. So we're going to have to consider what we need to do for a hood or some variation. I know I've seen on, I think, Dynacorn site, there is a hood with a scoop on it, kind of like, you know, the Camaro has a cowl induction style hood, and maybe that's what that's configured for. You know, and this, I'll have to look and do some more research, but that's a pretty good step up when it comes down to it. That's 4 or 5 inches overall. I can only kind of speculate because I can't go all the way across, but even there I have the edge of the fender pushes that up, so it changes the angle slightly. Gonna need clearance, so rough guesstimate, minimum 4 inches. Minimum. Yeah, okay. I'll see what I come up with, but now we know. Well, let's see if I can make a fake hood. We're going to find out. That is a box from the Camaro quarter panels, AMD, and it's going to give me plenty of material because the factory hood is only 48 inches wide at the back, and this is well over 48 inches. So I'm going to cut this up and make my own hood. So this is the typical cardboard aided design. I'm just going to cut this box and get the material that I need to make the dimensions that I need. So in other words, I didn't need to cut up the whole thing. I just trimmed it down to the length that roughly would be the length of the hood overall. So cut that off, get this section away from the rest of the box, and then I'm going to lay it out on the floor and take measurements from the car. And basically the hood itself is about 48 inches wide at the back, so I'm just going to center that up and come up with those dimensions, 24 on either side from center. And I forget what the front was here. It was like 46 or something, 45 and a half. I don't remember exactly right now, but it does taper. So I drew this out and just used scissors to cut that taper because it was a little bit easier than trying to cut it with a razor knife. Set it up on top of the intake manifold and get an idea of what it's going to look like from the side as well. So I didn't want to waste your time showing me cutting out the center section, but what I ended up doing was just setting the cardboard on top. I pressed down to found this line right here, and I drew a line on the outside, and then I measured side to side to figure out where center would be, or where the edge should be, I should say. And then I replicated that on the other side. And I allowed about a 1/2 inch. So that gave me at least that location. Then I came forward and I figured out where that center of this would be as well. And took some measurements, made some impressions, and just kind of hand traced this out. I did not use any template or anything, just a rough drawing. I also reshaped the back of the cardboard to kind of mimic the shape of the hood. So what I realized whenever I first set this on here is this was a little further forward because it dropped down on the cowl. So this, while it represents the opening, was actually a little further forward, and it worked out pretty well. I taped it up here so that it was back. Now I'm not against this. I mean, honestly I think it looks kind of cool to see that sticking out. There's going to be more involved when we get up here and add on the ductwork, so this shape may change a little bit. And here with the control unit for the throttle body, you can see this is wider, so it's not going to be symmetrical. If this were to come up, I would probably trim this back a little more here, and then this side I don't know if I want to copy it or if I would or not, but I can make it symmetrical, but it's going to have a bigger opening because of this. So I don't know, it might just work. It might just work and look kind of cool sticking out of the hood, but we'll see. I'll let the owner make that decision, but at least now we have a visual of what it could look like. Well, I've had some input from posts that I made on Facebook and also on the short that I posted on YouTube. One of the suggestions was using the scoop that was for the 69 Mach 1 that was also used on the 68 Cobra Jets. And while that's a great idea, it's not going to work. For one, it's not tall enough. So right now it is sitting on the posts that would normally go through the hood, and it's just not quite tall enough. You need about almost 3 inches of clearance over this intake. And also, this just wouldn't look right. You have this opening here, doesn't make any sense. So we're going to set aside that hood scoop because that's just not going to work. Another suggestion was the 429 Boss intake, and I'm looking at some of those. Now keep in mind, I have not gotten a yes or no on what the owner wants to do just yet. I think this looks kind of cool as the shaker style hood, but it's up to him if he wants to go that route or not. I'm just exploring options. So we know the Mach 1 hood scoop is not going to work, and I was looking at different 429 Boss scoops. So by chance, I found here's a scoop on Amazon, and it is 169, and according to the dimensions, it is 32 by 24 by 4.5. So 32 would be the length, 24 would be the width. So if I look at those dimensions, and even if I went all the way to the back of that cutout, 32 inches is way up here. And we don't have to go all the way to the back of that cutout, because this opening can actually be brought forward some, probably at least 2 inches. And that will also depend on the hood itself. Because I'm not using the real hood right now, there could be some cross bracing or something that would interfere. I'm just saying 32 inches would put it well ahead of the current cutout. And 24 inches, well, if we put this 12 inches on center, let me shorten up the tape a little bit. So we're going to go 12 inches to make the 24. And that would put it about 6 inches outside of the sides of this, maybe 6 or 7, depending on how, how it looks. So that is a thought. Could that work? It very well could. Now, I'm going to show you another one, just because. I don't know if it's an accurate dimension, but I found this other one from I think it's Tony Branda, I think is the maker. And it is 21.5 wide, 27.5 long. So let's look at that real quick. If I go to 27, so just happen to tape, look at that, it's right about on 27.5. So if I went roughly 27.5, just eyeballing it, that's a little bit shorter than the cutout that I made. So 27.5 would put it right at the front of that cutout. Now keep in mind the shape of the scoop. It doesn't come all the way up here. It angles kind of, you know, boomerangish in the shape department there. So the 27.5, I don't know what the dimension is from that corner to this relief area. I don't know. So while that may work, and it may be fine, it would cover up most of it, I think. But it would, you know, you still have this opening at the front here. And again, it could be brought forward slightly, maybe conceal it a little bit more. So there are variations out there that could work if we decide to go with a hood scoop. Right now I'm not sure, and I think the owner likes it with this kind of shaker look to it, but we'll have to determine that for sure. But just so you know, there are options, and either way it's going to look cool, I think. Because I'm curious, I just wanted to see how this would look. I do not have a hood, a smooth hood that doesn't have the turn signals. So this is the only option I have to look at the moment. But if I bring this template up, the rough template, and just set it on here, it gives me an idea of where that cutout would be. I feel like I've got it basically centered. So either I could do set the piece that I cut out in here, or I could just do a cartoon drawing just to see what it would look like, because I'm not going to cut up this hood to see what that'll look like. What I can see though is right off the bat, because we don't have the cardboard doesn't show you the dimensions or the shape correctly of the hood. You'll notice right now, let me just get a little bit centered up here. You'll notice here's the peak of the hood, and this is a cutout on the driver's side versus on the passenger side. And you can't get away from that. As I said, that throttle body has that big module on the side. If that wasn't there, you could make it match. So there's where we're at. Also, I'll show you from the side, because of that hump, we already know that there's going to be a gap. The center of the hood goes up slightly. So I'm going to take this off, pretty much where that cutout roughly would be. And with these turn signal lights, that's not going to work. That would not work. The only way I could see doing this is with a regular smooth hood, but yeah, that's not going to work. I'm going to turn the hood over and get an idea of where what inner structure would be in the way, and also point out we do gain a little bit. So now I'm kind of curious. I know I talked about this 351. Well, I know it wouldn't work anyway, because I already mentioned it's too short. But I'm going to set it on just to look at it, because we would gain a little bit of space with the curve of the hood coming up, you know, in the center there. But I don't know how well the scoop would fit either, because these scoops, the 69 hood doesn't have that peak in the center. So that would have to be customized here to make it sit over this peak, or flatten out the peak or something. But I'm going to turn the hood over and look at how that would lay out. Now with the hood upside down, and this being the bottom of the template, I can take the piece that I cut out and just kind of set it where it would end up. And that way I have a visual, see how close I am here, of roughly where that fits. So again, take this out of the way. And it does come up into this support structure, but not much. So looking at the back, it would be just ahead of, or right on the edge of, the inner panel or inner portion of the hood. So you got this cutout right here. Would have to cut into this cross piece and then probably cut out some of this forward structure. At least that's what I'm seeing. And then I don't know if what difference that would make overall. This is going to keep the hood shape correct. And then I think if you took this out, may actually end up taking it out further, like come out here somewhere and make a strap or something to hold this to this piece. Just a thought, because you'd be cutting out all that middle section. So just information here, you know, as we go forward, trying to figure out all this stuff and make things work. I want to show it to you so you know what it takes. Well, until a decision is made and finalized, I'm going to move on to do some other things. So I'm going to take all this back out. Take out the intake, pull the header off as I had mentioned, take some other things loose, take the fenders back off. I want to get the engine out of the way and start addressing other things that are a concern. And one of the things I want to look at is this right here. So as you know, these are one-piece dynacorn frame rails with aprons, shock tower delete, pre-assembled. And when they make these, they make their own, they have like an insert in here, so all this has a pattern to it. And I like the way that looks. But what I don't like is this right here. In my opinion, they should have had a piece connect these at the minimum. So what I want to try to do, I'm going to take all this back out of here, like I said, and I think I'm going to make a filler piece and try to blend this together. I don't want to fill in on top of this shock tower replacement piece. I don't want to mess with that. I also should point out they have these holes here, which were normal for the apron because it would have had that cover on it, and so I don't care for those either. Now we could drill through these and just put some nice looking bolts in there just for an accent, or weld them shut and grind them smooth. But I don't care for this. So I want to try to make a filler piece that'll cover this up and fill in this span between here and here and make it look nicer. Same way on this side. And this one you can see it's a little bit different because the forward apron isn't square. Like it's actually kind of curving a little. So not that that's a big concern, but if I make a piece, I can't just make a 90 like this side. I should be able to just bend something and make it work. But on this side, it may need a little more finesse to give it a nice transition. And this corner is a little tall. So normally what I do in that case is I'll cut right on this edge, shorten up this corner, and tack it back together so that it has a cleaner look to it. Just some things that I'm paying attention to as I go through this process. So I'm going to try to get the engine out, and I'm going to try to do it with the core support clamped in place. We'll see how that goes. I know I didn't need to show you all this, but it was kind of nice to take these pieces back apart and put them away in the boxes. New parts are so nice to work with, and it pays to put them back in their packaging, make sure they don't get any damage or anything like that. I set the massive plate back in place, run all the bolts down, and then I move everything out of the way, and I set up my hoist. Now, The hoist has, I've added poles on either side to help strengthen my roof trusses, because you definitely don't want anything falling as you're pulling an engine out. So I get the hoist in position, get the car in position, and I start lifting up. What you don't see is I got the bolts out of the way, and that's why I'm pushing down on the aprons so that I can get the mounts to come out of the receiving part on the cross member. So I'm playing with this a little bit. I do want to see if I can get this out with the core support in place. And what you'll see is the transmission lines. Now these, assuming we're going to be using these transmission lines, technically I could take them loose and get them out of the way, but I just really wanted to see if I could get it in and out without having a problem. And I can get it to go to a certain point, but I realize that the angle of the engine it's going to have to be like either really extreme to get it to drop in and adjust, because you don't want to mess up any kind of finished area. So once the tunnel is, all painted and treated and undercoated, you don't want to scrape the transmission into the top of the tunnel to make it fit. So I played with this a little bit, and then I decided I just need to take the apron, the core support out of the way, so it makes it a whole lot easier. So I take the clamps loose, wiggle the core support, get it out of the way, and then I move the car back, and it made it just a lot easier to do it this way. So slide the car back, get it out of the way, and I want to raise the engine here slightly just to get clearance for the tail shaft. And once I get it back, you'll see there's a block of wood that I had underneath the car with a jack, and that was just supporting the transmission while things were being moved. So I have this big cart, and I keep it up in my house garage. So that cart has been used for a variety of things, really heavy duty, more than enough to support this engine, but I had to get it inside the garage. So I do that, bring it in, start lowering the engine, and anytime I do this stuff, I want to make sure that the engine can't be like tipped over, because that would just be terrible. So I find ways to put in blocks and support it, make sure it's not going to fall over. And once I'm happy with that, I'll slide it to the side and then continue on with everything else. Now that I have the engine safely on my heavy duty cart, I'm going to start addressing some of these other things. You already know that I've done a bunch of welding on this, and there's welds that need ground down in different areas. I did some of it, but there's a lot more to do. And I'm going to address these areas that I talked about, but something has stuck out that I need to fix. Now, I make mistakes. I try to show everybody what I do, how I do it, and if I make a mistake, I want to point it out to you. So this piece right here that connects the apron to the cowl, I had the fender sitting on there, and I noticed that I did not have the alignment correct. And what I mean is this little recess here on the apron and this recess on this connector piece was not correct, meaning this piece is sitting too far inboard. Now, is it a big deal? Not really, but what ends up happening is the bolt hole is too far inboard, and you end up either modifying the fender or doing something to make it work, or maybe moving the slot. You could do a variety of things. You could cut this out, move it over, and work on it. But the more I looked at it, I said, nope, I'm not going to do that. So I noticed I left a gap over here. On that side, there is no gap. So I got that one nice and tight on the apron. But for some reason, I ended up putting this side tight, which is not seen, versus this side. And if you look at the driver's side, it's wide, so it sticks out a little bit right there. Doesn't hurt anything, but cosmetically, it looks better to have it tight here, and it also puts this more in line and takes care of that bolt location. So I'm already in the process. I can undo this stuff. I use a cordless drill and a 1/2 inch drill bit, and I drill through halfway through the weld. like you can see the ring there. And I'm going to remove this and slide it over and re-weld it. Also, I wanted to point out, when I was working on the cowl, and this is another thing that's been bugging me, is this little piece of metal right here. So I trimmed back the cowl just to clean it up. I wanted this to be a smooth line all the way across. And so if you go back to when I was working on this, you see how I did all this. But this little piece right here has been bugging me. And by removing this, I can trim that nicer and make it look better. So that's just another thing. But like I said, if I make a mistake, I want to show it to you so you can not make the same mistake. I'm going to get that loose, move it over, and see about welding it back on. To get this loose, I'm using the seam buster, spot weld buster tool from Steck. And I've had these for years. I have a couple different ones. The other one is like at a 90 degrees, so you could hit it sideways. But I realized it's not cutting well, so I stepped over to my belt sander and put a better edge on it. It happens. When you use these tools, they get dull and you have to just keep up with them. So I'm working my way underneath this panel, and you see I'm not wailing away on this thing. I'm gently tapping on it just to slowly cut through the remaining edge of the weld. And then I try to get these other inner pieces loose, and I switch over to a regular cold chisel because the seam buster is just too wide. Now this front section, I start working on it. I realize I got to drill out these welds a little bit more so that they come loose a little more easily. Now this Steck tool, I work it under the front edge and get these welds to break loose. And once I get this panel to come up slightly, then I'm able to go from the back side of the welds, and you'll see in just a second, and work on getting them loose from that direction. The Steck tool a little bit wide, come back with the cold chisel and pop it off, and then clean up the welds and get ready to weld it back on. So like I was saying, I had it too far in. There's my line, and by cutting it loose, cleaning it up, I can now slide it out. I just cleaned the holes, flattened out the pieces, ground off the excess weld. I still have to trim this off. I don't like that. I don't know if I'll come all the way out under this piece or not. It doesn't really make any difference. But right here, I want it to look clean. So now I'm going to put the fender up and see how that looks. And that is much, much better. That little pocket almost hides under the fender. Well, let me line the fender up correctly. So there. And a little bit too far over in the front. So yeah, that's a lot better. That's going to adjust that very nicely. And the other ones look like they're going to line up okay. So I'll weld that back on. Let me slide it back just a bit. Weld that back on, and that'll take care of this little area after I trim down that excess. I set the fender back in place to use as an alignment for that connector piece. So I can adjust the fender, pull it up just a little bit, tighten up the gap. I don't have all the bolts in it tight, but I will say that that bolt lines up, that bolt lines up. Where'd it go? That one lines up. And, oh, wait a minute. That one doesn't line up. That one does. And that one, well, it probably will. You can look and see where the hole for the fender is in relation to where the edge, like the hole is in this location. It looks like that fender hole is slightly inboard, and it should be more outboard. There's a lot of room on the side of these that kind of highlights that. So I may end up moving this hole inboard slightly. Back here, I took care of that gap. Look how pretty that is. I also cleaned up that corner, so now it's all nice and smooth. And I did blend down some of it underneath just to clean it up, reduce a little bit of material on the car. So this is now ready to weld back in place. I'm happy with that, and I'll continue on with trying to get this looking cleaner on both sides. So there it is, welded back in place. And I've been using, as you all know, this first test DP200. Really nice welder. I have links for that down below in my description box of my videos if you're interested. But it's welded back in, nice and tight on that inside. I think it looks really good now. And this is something, I don't know, I guess I didn't notice it before. So if I take this straight edge, and now I line it up specifically with that new hole location, and then I'm going to go to the ones that I know it lined up on. So those two there, that one, and almost that one. And what I found is, as you look at these, that's pretty much on the edge of the center line, center line, center line, and look where this one is. You know, I had drawn or put a mark there representing that this needed to go inboard, and this kind of defines it now. So you see that one's right, and that one we're going to speculate on because I talked about the hole in the fender not being in the right spot. So I may end up moving this hole just to accommodate the fender better. Just an observation, you know. It always helps to double check these things, especially before you get to the point where you're painting something. I did a little searching in my scrap metal, and I realized I still have these pieces that were left over from the tunnel project. So this is 20 thousandths, or 20 gauge, I should say, not 20 thousandths, 20 gauge. It's the same thickness as this sheet metal here. And then I set the fender on and drew a line so I would have an idea of just how far I needed to go, and I'll probably go a little bit past that to make this work. Now, of course, this isn't the right shape. I'm going to have to cut it and square it up, but it gives me what I need somewhere in there. There's always, I always say there's a patch or a piece hiding within what I have, and I feel like there's going to be enough here to make that work. I could even turn it sideways if I needed to. So I have two pieces of that. Now to start this process, I need to square up this piece of metal. So I'm just going to draw a line on here and then go to my throatless shear and cut that off. I like to salvage as much metal as I can and reuse what I can. So I put this in place, and I find that the measurement between these two edges, these two aprons, is actually square, and I want to make sure I get that correct. So I draw a line at the dimension that I need, which is about 7.5 inches, if I remember correctly, and I cut that off, and then I go back to setting the panel back between those two aprons. And what you'll see is the overhang. On the front, it's longer. So I'm drawing a line here because I want to bend this. I want to get almost a 90 degree. I start using this piece of angle iron because it has a very crisp corner on it. And I'm just gently tapping it down, and I realize I need something else. So I just took another piece of metal that I have and clamped it onto my piece of sheet metal, and then use a hammer. And you'll see I'm hitting it kind of sideways. I'm not going straight down. I'm hitting it just kind of sideways to help it flow or bend in that direction. And once I get that done, I take it back over and I fit it. And I realize also that this piece doesn't need to be at a perfect 90. It's got to be opened up just a little bit because of the way that is shaped. So I adjust that accordingly. And in the front section here, there's a little bit of a gap. So I make a little filler piece that'll go in there and weld it in to become part of that. Now, I arbitrarily picked a dimension here, and I drew these lines to cut off the excess material that I didn't need. I'm measuring or drawing a line on the backside because it's easier to cut that way with the throatless shear. That way you can see it. You can't turn it over and cut on the other side because it just won't work. So I cut that off, and I go back and refit it, make sure it's going to work. And as I said, I make a little filler piece inside of that. Now here I'm just marking off where I need the minimum dimension I need to be away from the edge so that the panel is covered up by the fender. So there's a good measure, or a good line, I should say. I have enough space here that I can cut this one from the top, come back over and verify those dimensions, and then all I want to do is cut a little bit of a notch here for the nut plate. So I'm not too worried about it being a huge opening, but I want to make sure it's close to being totally covered by the fender. So I'm just using some hand shears here, some tin snips, to get rid of the material. And once I get that out of the way, verify that it's going to fit the way that I like, and I realize that I need to sand down that front edge just a little bit to make it fit better, clean up the edges where I just cut with the tin snips, and then flatten out the metal a little more, and then come back over and refit. And right now it looks pretty good. I'm very happy with how it looks. Now I have this piece to cover that space, and I think it looks pretty good. Tight gaps, and I will, weld this in on both sides, weld it, and give it the impression that it was more like one piece. Also, I've drilled 3 holes here so I can weld it to this, and I'm going to punch some holes in the top. I'll probably put in more than I need, but while I'm there, I'll make that happen as well. And to do that, well, I don't know if I can get in far enough. I thought I could get in. Oh, maybe I can. Nope. So I can at least do these. And this tool, I've talked about it before. I posted links in the description box down below on my videos. This thing has been great. Available on Amazon. Does a great job. I'll probably have to just drill a hole there because I don't think I can. Well, you know what? That'll be fine. That'll be fine. I can skip those other 2 because it'll all get blended down anyway. And I've fitted the fender on there. Let me back this up a little bit. I set the fender up in place. Everything else just disappears. No back edge, nothing in the way. So I like it. The other side is going to take probably a little more finesse, but I'll get it made as well. I just need to weld that in. I'll also point out that I'm going to coat that with the Weld 2 primer on the back side. Here it is, blended down, mostly. The top is smooth. I think it looks pretty good. Now, I will say, you know, I left these segments off here. I cut this short. And I don't think it really makes any difference whatsoever, because if I had left that little piece there, it wouldn't gain any strength, wouldn't change anything at all. Besides, add a little more weight to it. So it just made it simpler to keep that off of there. I'm going to set the fender on so you have an idea of what it looks like with the fender, and we'll take another look. With the fender in place, now you can see it really didn't make any difference about those little pieces back behind there. This looks so much better, in my opinion. And I'm looking forward to getting this one done as well. Now, this one I'm going to have to play around with a little bit more, because this corner isn't correct the way that it's shaped. It's sitting up pretty high. And it's going to be the same process as doing that, except I'm probably going to cut right on the edge of this, one way or the other. I can cut here, and actually I should say I should cut here. Got that backwards. Cut this off and let this corner come down so it sits on top of this. You can see it sits up just a little bit. And even if I tried to use a hammer to knock that in, it's going to raise it up. There's nowhere for the metal to go, so I have to cut a relief there. And then I'll replicate the same piece on this side, and we'll see if I can't get that done today as well. Just to show you what I did here, I made that cut, tap that down, got the transition a lot better. That'll get welded and blended to look more like this shape. And I've made the new piece, so set that in. Same situation. This one, this cutout was a little more offset, I guess. On the other one it seemed like it was in further. But either way, I'm going to weld that in, blend everything smooth, and it'll look like that side, hopefully. The other side turned out really nice. So everything is underneath the flange for the fender. One other thing I talked about earlier, I still haven't addressed, is relocating that hole slightly to make it work better. But I was looking at that a little more. When you look at the gap on that fender, and here it's consistent, looks the same. This one is wider. And you look over here, this one's not as wide. And these are more consistent going all the way back. So I feel like that hole is just in the wrong spot. And I'll have to move it, make it better. But this is looking pretty good. I'm still grinding welds. You know, I cleaned up some of these over here, and I was working on some around the windshield frame, or the windshield opening. There's a lot of grinding dust on the floor, as you may already guess. But it's things like this that I'm addressing that pay off later. As I always say, you know, if you're doing something, look at how it's going to turn out at the end, because you might regret some things you did or didn't do. Now, the only other thing that I'm questioning, and I'll get with the owner on this, is these holes here that I talked about for what would be the cover, and whether we're going to weld those shut, which is simple enough. I may end up just doing that, or put some cool looking bolts in there or something. I don't know. Not a priority at the moment, but getting this other stuff taken care of is. I'm going to be working on the bottom of it and grinding welds in the tunnel and all kinds of different stuff. So plenty more to do. Well, this video is kind of all over the place in a sense. I know that I covered a lot of ground, meaning I started off test fitting the intake manifold and accessories to see what would work. And that came to the realization that the hood would not fit. And so I made my own template for a hood, showed that, and what may or may not happen, I don't know just yet. I'll get with the owner and see what he wants to do. It may end up with a hood scoop, or it may end up being a shaker style. I don't know. But whatever he wants, I'll do that. And that led to pulling the engine back out and addressing some of the ugly stuff with these aprons. And of course that led to grinding and welding and fitting and making pieces and all that sort of thing. So I hope you got something out of this video. You know, I always talk about what's going to happen, you know, next. Like if you're putting parts together, what do they interact with and how is that going to work? And so hopefully you got some information that will help you if you want to do something similar on one of your projects. But that'll be it for this video. So I want to thank you for being here, and I want to thank my patrons especially for helping support me in making these videos. If you're interested, as I say every week, there's a link in the description box down below for my Patreon page, and anything that I endorse or promote on Amazon or other equipment. So if you look down below, you'll see all that. Otherwise, that'll be it. So until next time, take care of yourselves. See ya.